Hello, Kirtan, I'm audible.
Yes, sir.
Alright, so I shared my screen. I hope you can see.
Yes.
Okay, in the last class, Kirtan, did I give any problem to you? Sorry.
No, sir.
Nothing, right? I think we were discussing about magnetic self-induction basically. We had a small discussion what is self-induction and all, right? So we get the small formula for that too.
Yes.
Alright, so last thing which we discussed is if you have something like this. We discussed about there is something called inductor. We said there is something called inductor. How it looks like this kind of thing. Okay. So we said if current is there, if you increase your current, if current is changing, the magnetic field is changing. Magnetic field changing creates a flux change. Now you know because flux is changing inside a loop, there will be some induction, self-induction EMF, right? This induced EMF is going to generate. That is one thing we discussed. Okay, that is in opposite direction. We did this discussion in the last class itself. So today's agenda can we go with so look it now. This is one we had. I'll just make two circuits. Okay, this is your resistance. This is your battery, and this is assuming it is your key. What it did is initially, if you see, there is no current. Okay, initial current is zero. Okay, the moment you close it, what will happen? Krishna? We are very well aware of that. This current I, this is I graph, this is time. Okay, what will happen the moment you switch on that curve? If this is zero, initially current is zero. The moment you do it in a very small time, very small period of time. Okay, assume this is zero, so 0.5 second. I'm just talking about 0.5 second, or let's say it's 1 second. In this very small period of time, this okay, in this is going to reach direct high current, highest value. What is the highest value? Can you tell me? Is V by R. Is that clear, Krishna?
Yes.
Okay, so I'm just asking you, what if I have another circuit, something like this? Do we get the same result in this case also? My question is, if this is switch, okay, if I just close the switch to this battery, this is inductor I, okay, this actually the value of inductor is it is written by L value. If you could remember the last class I discussed, okay, this is inductor I. So, do you think the graph I'm going to get the same or something different? Just think of it right now. Do we get the same graph or something else is there going to be there? Look, very simple idea. Assume there is no current in the circuit. It means there is no current in the inductors. Okay. The moment you switch on the circuit, current I will come. The moment current I will come, there will be some magnetic field. Assume a very small point. When you encountered with because look, current is what? Current is basically flow of charges. So when the first charge came, understood? When the first charge came, you got some magnetic field. It means at this moment there will be change in magnetic field. What was the change? Initial zero magnetic field, final some value. So this change is very high. It means this change is going to generate some opposite electric field. Okay. So from this side, this electric field will generate some current. Okay. So this is going to get cancelled. Makes sense. After this, because current is still coming, so this will increase the magnetic field by a very small amount, some dB. This will provide another chain flux. So it means now you will be having this current, but the extra amount of current which you were supposed to get due to extra charge, that will be opposed by this part. Okay. Then so on and so on. So what you can see is your current will not be reaching very high initially because you can see you have a zero initial current. Zero. Then you got some amount which is this much, which is not opposed. Then after that, this. Okay, it is growing current. Okay. So what kind of current you can see? This graph will look like growing current, something like this, and it will reach saturation. What is the saturation? The final value. Is that clear, Kirtana?
Yes.
Okay, so if I ask you what is the value of this, so this will come out as, okay, this final value is nothing but, if I just keep a resistance in the circuit, so it will be nothing but V by R. Why? Because when you are reach the final value, assume you are here, current is not going to change. If current is not going to change, magnetic field is not going to change, which makes flux zero. Change in flux is there. Change in flux is zero. Change in flux is zero. Final opposing EMF is zero. Understood? When you had this kind of thing initially when you started, you give all the current. This all the current will make a sudden magnetic field. That sudden magnetic field is going to get opposed by an opposite EMF. Who is going to generate this EMI is going to generate. Okay? After this, more current will come, more magnetic will come. But the previous part of the current and magnetic field will go, what I can say, unrestricted. The extra extra amount of current is that is going to be reduced by this magnetic field. Okay, this V is going to decrease by the time. So this is all about small thing. Okay, now we can actually move ahead and try to calculate the value. So Kirtana, look, now we wanted to calculate potential difference across inductor. Okay, how we can calculate? If I ask you, your task is to calculate magnetic field across, sorry, potential difference across this, right? So how you can actually calculate it? You know, when we had a resistor, right? We simply say if current is going from this side, it means this is a higher potential, this is lower. So whatever the what is the potential the drop across this IR, right? Or if you know this potential at this point, potential at this point. So delta V is this, or delta V is VA minus VB. Okay, this is in case of capacitors, you had something like this is one plate, this is another plate. If you know the electric field inside, you can say V comes out as E dot L, whatever the length is there. If you know the potential at this point, so this V delta V comes out as VA minus VB. Also, you can say if you know the capacity, or you know the charge, so Q is equal to VCV. So this results you answer as delta V comes out as Q by C. These things were there. What about inductor? What is the potential across inductor? So basically, if you think carefully, this inductor is nothing but a simple wire. Okay. What happens? It basically opposes you. For example, if current is growing, what will it suppose? It will be generating EMF in such a way that it can produce current in opposite direction. Understood my point? Because of this kind of condition, you are going to get this current. So it will oppose, it will create a magnetic field in this when this current is growing. Understood? When this current is decaying, what means to say this is decreasing. To maintain the same current for that particular moment, it will make current in the same direction. So this is for the to support the decreasing current. This will be the case to oppose the increasing current. Okay. So what is the value for this? This is what we are supposed to calculate. Main current increase. Okay. So we have to calculate it. Understood so far? Okay. So Kirtana, if I move further and I ask you, this is my inductor. Okay? You know that this point may be VA, this point is VB, right? You know the potential will be nothing but VA minus VB. But if you can see this potential is due to the this is induced potential, right? Otherwise it's just a simple wire. Okay. So in case of inductor, what is the induced current? You know, flux change. You know, flux is directly proportional to I. So we said flux is Li. It means EMF change is nothing but d phi by dt. Can I say this? So can I say this change in this extra EMF is because of this change in current part? Can I say this statement?
Yes, sir.
Okay. Look, if you feel any doubt is that, please let me know. Okay? Why? Because look, this situation seems like this actually seems like this thing, okay? A, B, A is acting as a A, B. Why? Because of increasing or decreasing current. Look one thing, look carefully. If in your wire the current is decreasing, you know this is connected with this thing. Decreasing current means decreasing EMF. To support that decreasing EMF, there will be a current in this direction. How? This by using this kind of EMF. If it is increasing current, mean to say change is big. It means change is bigger. It will make a opposite EMF to decrease that current. Okay, this is what it is going to be. Be careful with the sign convention by using Lenz's law. Okay, so so look, I can simply say if your current IA, sorry, if your current is decreasing, increasing, then your EMF will be in this way. Sorry. Hello, Kirtana. Yes. So be careful. Right now, I'm saying current is increasing. So can you tell me across this EMF? I'm not talking about the wire. Across this inductor, which will be higher potential, which will lower potential, or what will be the direction of EMF in this inductor?
VB has higher potential.
VB will be higher potential, right? Because oh wait, this VB is higher. Meant to say something like this. Wait, wait. Your current is also increasing. Okay. Look, please carefully look at this. Your current is also increasing. You made an EMF inductor, like EMF across inductor like this. It means this is also increasing the current. So can I say this was also increasing the magnetic field? This is also increasing. Isn't it against the Lenz's law? As per the Lenz's law, if magnetic field is increasing in this direction, you have to you have to induce a magnetic field to oppose it. And that's to oppose something, if it is my current is this way, your current should be this way. If this EMF is this side, your EMF should be this way. Understood my point? So with respect to this thing, this point current should be this way. Okay, EMF should be this way. All right, let it be. Okay, let's solve one more problem, and we'll see it how it works. Assume that you are having a point A You have a resistance, you have this thing, okay? And assume the L is given as 2 Henry. Here the resistance is given as 5 ohms. This is point B. Sorry, this is point B. Okay. Also, you are given that and current isn't going this way sorry, at any instant, I is 4 ampere. Clear? I is 4 ampere, and change in current per unit time di by dt is coming out to be point 5 amperes. Clear? You need to calculate x value. Find x. Look, let's do one thing. Find VA minus A. Can you calculate this, Krishna? Let me know the answer. Calculate it and let me know. Krishna, please calculate the answer for this one.
Sir, is it 19?
No, Krishna, it's not 19. It won't be 19 actually. It's not 19 actually. Look at this. Krishna, should I give the solution for this one?
Yes.
Okay, look at this carefully. You are given this kind of wire, right? Assume at this terminal the potential is x. Assume. Can I say if here the current is potential is x, what is the potential at this point? Because look, this is 5 ohm, current is given as I. So can I say potential drop across this is 4 into 5, that is 20. Can I say potential at this point is nothing but x minus 20? Can I say this?
Yes.
Okay. You got the potential at this point. What is the potential here? You know that because di by dt, change in current is this much. So what is the EMF generated due to this thing? That is L di by dt. That is, wait, what is the value of L? 2 into 0.5, that is 1. Clear? Also, look at this carefully. This is negative. This di by di, look, di by dl is positive, right? So potential comes out as negative because we have to oppose it, right? So this comes out as negative. It means here should be potential will be this way. Understood? Is that clear? So what is the potential here? Here the potential is this much. X minus 20, if you subtract this 1 because this is an opposite direction, minus 1. Can I say you have reached VB?
Yes.
Okay. So what is VA minus V? VA is X minus X minus 21. What is this? 20. Clear? Any doubt, Kirtana?
No.
I hope this is clear. Right? Alright, I'm giving you another. Please get me the answer for this one. Okay? Yes. Calculate VA minus VB. This is what you're supposed to calculate. Hello. कल सबमिट करूंगा मतलब तेरे
Sir, is it 51?
Yeah, कितना? What's the answer?
51?
51. How is that 51? It's not 51. Look at this and carefully solve it once. Okay, I'll just give it once. Potential X What is potential here? 10 into 5 x minus 50. What is potential over here? Again, this time. Very simple. How to get the direction? It's a very simple idea to use. Simply say here, whatever the E you have to keep, that is minus L di by dt. General direction of I is in this way. So assume that, just assume, just for a while, just assume it like this. Okay, this is the battery. In your condition, what is the answer you are getting? L di by dt in a negative sense. This is your EMF. So minus L is what? 5 into point negative. The whole thing comes out as how much? 1 volt. This is positive this time. It means if you put it, yes, it is valid. So this EMF is basically how much? Sorry, wait. Yeah, this is actually coming out to positive, right? Because we are assuming the opposite current is positive. Opposite current is positive. What does that mean? This is something like this. This is 1 volt. So x minus this. You are getting from a lower increasing. Here this is increasing. The difference is increasing. So this minus this is for 50. So that is here if you reach it will be x minus 50 plus 1 because they are going from this one. So VA minus VB is equals to x minus x minus x minus 49. Kirtan, this is the answer, but let me know what's your doubt.
So can you explain how to get it like minus or the plus in LDID?
Yeah, Kirtan, what's your doubt?
I'm not getting to see the directions.
Okay, look. Okay, so I'll actually give you the way. Look, Kirtan, the problem is, in general, just get the normal direction, right? Okay. Say that the external battery, look, very simple idea. This is going to act as a battery in future, okay? So replace it with a battery. Why we are replacing it this way? Because we are assuming a normal current, okay? Normal current. Or you can simply say you have to keep a battery at this point. Don't say what is the direction. You know that, look, please look at this carefully. You know here, whatever the battery you are going to get, the value for that is minus L di by dt. What is direction of I? Please look at that first. I is in this way. Okay. So simply assume your battery is in this way. This kind of battery is there. Okay. And whatever the value you are going to get, you have to achieve that. So in this problem, if you see L was something answer, whatever the answer for that, what you got? 1. 1 volt mean to say you assumed the direction to be this and you have got positive. It means this is the battery direction. Is that clear? Kirtana, is this part clear?
Yes.
Okay. Look at this previous problem. In this previous problem again, I said this is my inductor. Replace it with a battery. Why this way? Because current is in this one. Makes sense. Okay. So you have to support this current. So assume it. Now when you calculated this thing minus dl by dt, what is the answer you got in that? Okay, it is negative side. Here you got the answer is negative. What does this mean actually? It means you assumed to be this direction, but it is coming out a negative. So what you need to keep? Simply minus 1 by this. Is that clear? With a 1 voltage. Now it's fine, right? And if you are thinking, if you can't think in any way, simply say you are going in this direction, okay? And simply whatever the value you are calculating, just add it in your answer. That will result you the answer. Okay? You just simply assume if you don't want to think too much, remove it from you. You are coming from this direction to this direction, okay? So whenever you are coming from here to here, you simply add minus dli by dt. That's it, nothing else. Don't have to think on it. So look, you just need to solve too much problems. Like if you solve 10 to 20 problems in these kind of problems, you'll get the answer. Okay. So I'll give you another problem. Try it once. I think I gave the solution, but is equals to 49. That's fine. Okay, Kripal. Example 2. Here I'm having this is point A. I'm having an inductor. I have another battery, and assume there's a let's start with some resistance, battery, inductors. You reach point B. Um, this is 4 ohms, 10 voltage battery is there. So this is 10 volt, and here you have around 2 Henry of this. Okay. Also, your current given current as currently the current is 3 ampere, and this varying current dy by dt that is coming out as negative 2.1 ampere per second. Try it once, get me the answer. Just try it once in a similar way you have to done the previous same way you have to do this also.
Is it 1.8?
No, it's not 1.8. You have to calculate net potential, right? Change of potential from A minus B. How you're getting 1.8? It's very low. Just look at your equations once again, Kirtana. Please look at this once again.
Yeah, 31.8.
Mm, Actually, look, this answer is better than your previous answer, but still there's some error. Look at this once again. Okay, you're near to it. You can actually get your answer, but you're doing some small mistake plus minus. Look at your equation once again.
Sir, can you explain?
Yeah, okay, I'll just explain. Look, assuming as look previously, assuming this to be x, okay, you are reaching from here to here. So what is the potential here? X. What's the potential here? X minus 12, right? Now assume you are reaching from this point. So what is the potential should be here? Can I say x minus 12 minus 10? Is it going to be potential? Is this clear, Kirtana?
Yes.
Okay, makes sense. Hmm, anything else we are left with? No, that's the only thing. Now you are having Henry, right? So what you need to see simply E is equals to L negative of L. Sorry, this is L di by dt, right? So this is minus 2 into this is negative in this, right? What is the answer you are getting? Around zero point 0.2. Can I see this? So basically, you just have to add it. Why you are supposed to add this thing? Because we are going in this way. We assumed battery to be looking like this. I resulted out something which is positive. It means my assumption is same. Okay, my assumption is same, so I can put battery like this with potential this. Potential this means to say you are going to add it. What's the answer you are going to get? X minus 21.8. So what is the BA minus VB? 21 point. Is that clear?
Yes.
Okay, makes sense. Kitna, try it once. Actually, I won't be able to take till 9:15 today. Try it one more session. Sorry, one more problem. I'll be getting actually problem like this only. After this, just take one more problem. Okay, are you a little bit getting clarity in choosing the direction or still have same doubt?
No doubts.
No, no, no. No. Like I know doubts may be there, but it only depends on how many problems you are going to practice. Okay, because when you are solving the things in a person, you may not be getting the things. Okay, 2 ohms. This is going to be your gate voltage, and assume it to be 5. Current is I. Here your I is how much? Hmm, assume current to be 5 ampere. So Kitna, that is the case. Look at calculate VA minus VB.
So the value of di by dt.
Uh, for which one? I think I've given all the values, right?
Di by dt.
Oh, sorry. DI by dt I didn't get. What you can assume DI by dt. Okay, let's say DI by dt is zero point 0.4. Yeah, maybe take it as 4.4. How much kitna?
20.
20? Okay, so actually if you have got 20 answer, it's incorrect. What is your answer? Kitna, what's your answer?
20.
It's not 20. It is incorrect. I think you may have got it incorrect because of this I itself actually. In this case, look, in the previous case, my I was in this direction, okay? Here I have changed everything completely and my answer is my I is in opposite direction. Understood? So if you have to, if you just make all the current I is in this direction, current I is in this direction, okay? So let's solve it once. Potential here is X. Current we are going from lower to higher potential. So what is 2 into 5? That is 10. Mean to say, here potential is higher than this. Here is lower. So to reach here, what is the potential at this point? Potential at this point will be x plus 10. Then you got 8. Subtract it. Yes. Sorry. Yeah, you have to add it actually because you are going in lower to higher, right? So it will get added. Then you have this L di by dt. Because look, yeah, again two kind of assumption you can have. What one assumption is assume current is going in this way. It's incorrect assumption because right now your current is going in this way. Current is going this way, it means so you have to go with this kind of assumption. You do L di by dt, right? Di by dt. L is how much? 5 into zero point 0.4. Negative is there? So yes, negative is there. So if you go and put this answer, what you are going to get? This is basically results in minus 2. Okay. What does minus 2 suggesting you? Minus 2 suggesting you whatever you assumed is incorrect. You have to go in an opposite direction. It means this is your assumption should be. You assume to be this, you got minus. It means your assumption is incorrect. Make it like this. Did so you are going from lower to higher. Add the 2 again. Why 2? Why not minus 2? Because you had changed the direction. Okay. This negative was just to get your direction. At the end of the day, you know the magnitude that is 2. 2 volt. So this gives you the answer as x plus 20. So what is VA minus VB? That is x minus 20 gives you negative 20 as the answer. Clear? That's the answer, Kirtana. Any doubt? Okay. All right, Kirtana. So that's all for the today's session. Yeah. Actually, I can't take it. Yeah. Kirtana, any doubt you have which you wanted to clarify once?
No,
Look, I'm explaining you. I'm just telling you. In the next class, we have to talk about the energy. Okay? So if I ask you what we have to discuss, tell me energy because I may get forget. Okay. We are going to discuss energy of inductor. Okay. Please remind me if I ask you. So yeah, Kitna, that's all for today's session. I'll end the session by this.